So yesterday, we were talking about the product of powers property, right? And so we talked about multiplying exponents and, that really the rule is we're going to keep that base the same and we're going to add those exponents. So today, we're going to talk about the quotient of powers property, all right? So I'm going to draw a line right here, and we're going to add that onto these notes. We're going to talk about the quotient of powers property. And I feel like I'm going to spell the word quotient wrong. C-U-O-T, quotient of powers property. Right? And so just like yesterday, right, we want to think about what these words mean a little bit. So quotient, right, is division, is the answer of a division problem, right? And powers just means exponents. Okay, so something along the lines of like 7 to the 5th power divided by 7 to the 3rd power. So notice this is in a fraction form. So a fraction means division. So as we get into 8th grade math, and your book does a little bit, but that's your book. It's not typical. Like the old-fashioned like division symbol that you're going to see between numbers, that's going to kind of disappear. And if you really think about this division symbol, notice it's a line with 2 dots. Well, guess what those dots are? They represent the parts of a fraction. Okay, so really the division symbol is just a picture of like a generic fraction. So you're going to be seeing your division in fraction form. Okay, so we're going to switch over to the example from your book and kind of look at that pattern and see what we can learn from that. Right, so we're looking at example B. What they've done here is they have, right, this is 4 to the 5th divided by 4 to the 3rd. And so, right, 4 to the 5th, so they've expanded those values out, okay? So, right, when you say 4 to the 5th, this is the same as 4 times 4 times 4 times 4 times 4, right? When it's stretched out like this, we call this expanded form. Right, and you would have seen that like, in your younger grades, like if you said 452, and then you said 400 plus 50 plus 2, expanded form. So you break it apart, right? This is just expanding that out. So, and then 4 to the 3rd is down below. Okay, so what they are doing here is this idea that if you have 2 equal values over each other, right, that this makes a giant 1, right? So 4 over 4 equals 1. 4 divided by 4 equals 1. So 4 over 4, I call it a big Arnold Schwarzenegger 1, right? So this 4 and this 4 make a 1, right? This 4 and this 4 make a 1. This 4 and this 4 make a 1, and they cancel each other out. And so what are you left with? You are left with 4 times 4 in the numerator, okay? So what that means is you would always still have a 1 down here. So remember, we could have said 1 times 4 times 4 times 4, and that would have not changed anything. So really, this is like 4 over 1, and then 4 times 4. So we could have said 16 or 4 to the 2nd power because that 1 can become invisible. Okay, so same question we had yesterday. What pattern do you see when dividing with 2 powers with the same base? So I'm going to stop for a second. I want you to think about what pattern you see.